Hello, my fellow mathonauts. So this is a puzzle which dates from 1544 in Europe, and it's been modified slightly to meet the YouTube guidelines. And what it is so we have a group of 20 people, men, women, and children, are going to an inn for a meal, and together they spend 18 thaler. The men pay 3 thaler, the woman 2 thaler, and the children half a thaler. And the thaler was a unit of currency. It was basically like a silver coin back in the day. So the question is, how many men, women, and children were in the party? So let me present what I think would be a pretty clear solution. Before I continue, I should introduce myself. My name is John, and I'm the owner of this channel, dedicated to clarifying various math concepts that people run into, both in the way of math education, and also we like to have a little fun with recreational math. So we do riddles such as this, and then we use these riddles to kind of clarify various math concepts. So if you'd like to contribute to my mission, please don't hesitate to subscribe and hit the notification bell, because that'll allow me to bring this content to a wider audience on YouTube. So we can solve this riddle using a little bit of algebra and then a little bit of logic and common sense. So towards using algebra, we're going to just use symbols to stand for the number of men, women, and children. So we'll let M stand for the number of men, W will be the number of women, and C the number of children in the party. So from the statement of the problem, we get that M plus W plus C has to equal 20, because there were 20 people in the party. And then as far as the cost of the meals, each man pays 3 thaler, so we multiply 3 times M. Each woman pays 2, so we multiply 2 times W. And the children are a half, so we multiply the C times a half, and that should add to 18. So we're going to use a process called elimination to get rid of the C variable, and that'll allow us to solve the riddle more easily. So we have our two equations here, which I've labeled 1 and 2. And in order to do this elimination, we're going to multiply both sides of the first equation by 2, and then subtract the second from the first. So we have 2 times the first equation is equal to 2 times 18. So I've copied down the two equations, and I've merely applied the distributive law. 2 times 3m gives us 6m, 2 times 2w gives us 4w, and 2 times a half c gives us c. Finally, on the right, 2 times 18 gave us 36. Now subtracting equation 2 from equation 1 gives us 6m minus m is 5m, and 4w minus w is 3w. Then, of course, c minus c is equal to 0, so the c's cancel out when we subtract. And then finally, 36 minus 20 is equal to 16 on the right. So the equation we have to work with is 5m plus 3w is equal to 16. Now let's just go through the possibilities for m to see what m might possibly be. Keeping in mind m was the number of men and w was the number of women in our riddle. First, if m is greater than or equal to 4, we can see, because 5 times 4 is 20, the left-hand side would be too big, because 20 is greater than 16. So m has to be less than or equal to 3. Now, let's look what happens when m is equal to 3. So plugging 3 into the equation above, we get 5 times 3 plus 3w is equal to 16. So that's 15 plus 3w is equal to 16, which, if we subtract 15 from both sides of the equation, we'll get 3w is equal to 1. But that's not possible because w is a whole number. So we can exclude m equal 3 as a possibility. What about m equal to 0? So once again, we'll plug 0 into our equation. We'll get 5 times 0 plus 3w is equal to 16. 5 times 0 is 0. And 0 plus 3w is 3w. So we get 3w is equal to 16. But that's a contradiction, because 16 is not a multiple of 3. So m equal to 0 is not possible. Now what about m equal to 1? Once again, plugging it into our equation, we get 5 times 1 plus 3w is equal to 16. 5 times 1 is 5, and subtracting 5 from both sides of the equation gives us 3w is equal to 16 minus 5, which is 11. But once again, 11 is not a multiple of 3. So this is not a possibility. The only one that remains is m equal to 2. And so if we plug in 2 for m, we get 5 times 2 plus 3w is equal to 16. So 10 plus 3w is equal to 16, which gives us that 3w is equal to 16 minus 10, which is 6. And that gives us an answer of w equal to 2. And this must be the only possibility. So there's only one correct answer here. Finally, if m and w is equal to 2, we can see that c must be 16, since they must add to 20. So we have an answer to our riddle. The number of men is 2, the number of women was 2, and we had 16 children. Finally, we can verify that our solution works by plugging them into the original equation. As we noticed before, 2 plus 2 plus 16 is equal to 20. And then 3 times 2 plus 2 times 2 plus 1/2 of 16 is 6 plus 4 plus 8, which is equal to 18. And that's the answer to our puzzle, and thanks for watching.